Hey y'all, welcome back to another LeetCode video. So problem 572, this question is asked by Amazon. So we're getting the roots of two binary trees, root and subroot, and we return true if there's a subtree of root with the same structure and node values of subroot, and false in the other case. And then we're given the definition of a subtree, that being a binary tree consisting of nodes in the tree and all of its nodes descendants. And the tree can also be a subtree of itself. So in this case, we're given a subroot tree with nodes 4, 1, 2, and we return true because it's in the same root binary tree 4, 1, 2 in the same structure. In this case, we return false because although there's a 4, 1, 2 structure that is the same in the root binary tree, there's no left child node, as this number 2 node has a left child node of 0, but that isn't apparent in the subroot binary tree, so we return false. This invalidates the criteria of having all the nodes descendants, so that's why we are returning false. So when approaching the solution, two things come in mind. First of all, we need to do some sort of approach that is traversing the binary trees, and then also being able to keep track of all the nodes that we visited. So to address the first criteria, traversing, we can do a depth first search approach. So there are three types of traversal methods: pre-order, in-order, and post-order, and the variations between them are very minimal. In this case, I'll be doing a pre-order approach. So I wrote some kind of pseudocode or some very basic structure code of how a pre-order traversal works. So you pass in the relative parent or root node that you want to start with, and then we print, or in this case, I'm adding to the stack the node value, and then we recursively call the left subtree relative to that root node being passed, and then we recursively call the right subtree of relative to the root node that we are being passed. So yes, and then to address the second part is we are appending each node value that we've visited and adding it to our stack. So in our actual LeetCode code that we'll be writing, I'm going to be having two different functions. So one to call the pre-order passing in the root binary tree, and then one to pass in the sub root. So this will create two different stacks. I didn't write the variable or else it would be conflicting, but you get the idea that we're having two separate stacks right here for each binary tree respectively. So when I do that, in this case, we'll be having this stack output for the root tree and then this stack output for the subroot tree. As you can see, there's some null values in place because we have 3, 4, 1, and then we have two nulls because the 1 doesn't have any left and right children. Same thing with number 2. There's no left or right children. And then 5 doesn't have any left or right. In the same case with the subroot is that there is no left or right children. So therefore we have those null values in place. And then lastly, if you observe you might see that this is kind of, the second stack is a subarray that's placed inside this main stack or the root stack. It's right here. So you have 4, 1, null, 2, 2, null, null. That is the same thing as this stack right here. So we're going to need some sort of method to kind of traverse and find where we have this in place inside our actual stack. So where is stack 2 placed in stack? And then we return true based off that. The way we're going to do that is compute some sort of way. So we're going to get the length of the stack. So in this case, it's 11. And the length of the second stack, in this case, it's 7. And then we just add 1. So this computes to 5. So this means we're going to have 5 iterations of this in place to go over traversing this array right here. And the reason we have this is because we don't need to check positions where there aren't enough elements left to match the subarray, because obviously there's a smaller subarray inside the big array, so we don't need to compute every single position like that. So I'll be creating some sort of window of size 7. And then we're going to be iterating 5 times, and you'll see why, because we can match 1, 2, 3, 4, 5 until you reach the end of the array. Hence why we have it 5. So first iteration, you'll see that this subarray doesn't match this, so we iterate one more time, and as you can see, now this window, this sub window matches this array right here in the stack. So now we can exit, and then we can return true. We don't need to iterate anymore down the stack. So that's kind of the approach of today's problem. So I'll be having we'll be writing our pre-order function. So that's going to be taking in some sort of node. And then what we're going to do is if the node is none, that means that if there's no children, then we can just return some sort of null value. And if it isn't, then we can return, I'll be turning this into an f string. So we'll be having the node value, and then we'll be able to recursively call I'll just add traversal right here, make it easier. Recursively call the left subtree, and then the right subtree. There you go. And I'll have two different stacks. So stack 1 is representative of the root stack, or I can just rename this as root stack. And then I'll call the function on the root, and then subroot stack of the subroot. And that'll create my stack array as we just saw in the example right here. And then I'll be creating two different variables. So one to get the length of the root stack, and then one for the length of the subroot stack. And then we're going to be computing the amount of iterations we need to do, as we just saw in this example. So this thing right here. So for I in range of the bigger stack, which is going to be the root stack minus the smaller stack plus 1. And what we're going to do is have that kind of window that we just saw right here. So that's going to require array slicing. So we're going to create our kind of window, and we're going to be like, hey, if the window that we're looking at, starting at the I position to I plus m of the subroot stack, if that's equal to the subroot stack of itself, then we know that we found the same values right here. So we can exit and return true. And if that never happens, then we just return false. Oh, tree node object is not subscriptable. Did I have some sort of error? Oh, sorry, root stack. That's what I meant. Yeah. You can see solution worked. It's a pretty fast solution, I'd say. O n plus m time. And that's how you do it.